Welcome you all for this short video on programming GCD. GCD is greatest common divisor. Another name for GCD is HCF, highest common factor. Let us see a small example. GCD of finding GCD of 4, 6. Any perfect divisor of 4 and 6 should be less than or equal to 4. Then consider the sequence starting from 4, 4, 3, 2, 1. In this sequence, 2 is the first number which perfectly divides both 4 and 6. Hence GCD equal to 2. Pause the video and try to write a pseudocode. So the first step is among the two given numbers, you have to find the minimum number. Then second step is you have to check whether the minimum number divides both the given numbers perfectly. If not, you should decrement the smaller number. You have to repeat the step 2 again and again. So if you want to repeat the step again and again, you have to use a loop. Hope you have selected the while loop. Look at the slide. So GCD1 of A comma B is the function name. You have to find the minimum of the two given numbers. Let it be assigned to T. Then you are checking whether both the given numbers perfectly divides the T. If not, you are decrementing T. So you are repeating again and again. Here you are using while loop because it is a condition controlled loop. When the condition gets satisfied, it will repeat. If the condition is not satisfied, it will come out of the loop. Let us look at another method for finding GCD. Finding the GCD of 4, 6. Take the bigger number and separate the smaller number. So 6 minus 4 equal to 2. Then discard the bigger number 6. Consider the other two numbers. Then separate the smaller number from the bigger number. Among the two numbers 4 and 2, 4 is bigger and 2 is smaller. So 4 minus 2 equal to 2. Again discard the bigger number 4. The remaining two numbers are 2 and 2. 2 minus 2 equal to 0. Hence GCD of 4, 6 is 2. This is another method. Pause the video and try to write a pseudocode of your own. So in the pseudocode, you should have two variables for storing the two inputs. Then you have to find the bigger number among the two and you have to separate the smaller number from the bigger number. Look at the pseudocode GCD2 of A comma B. Input is A, B. In the previous case we have seen, we have repeated steps again and again until it becomes 0. When it becomes 0, when both the inputs are same. So while A not equal to B, that is the condition. If A is first number is bigger, then you have to subtract second number from the first number. Else you have to subtract the first number from the second number. You have to repeat again and again until it becomes 0. At the last step, when it becomes 0, both the numbers will be same. So the condition is given as A not equal to B at the while loop. Another method for finding the GCD is Euclid's method. The formula is GCD of m comma n equal to GCD of n comma m mod n. You should apply repeatedly until you get the second step GCD of m comma 0. When any one of the input is 0, you can simply write the output as m. So look at the example GCD of 8 comma 12. Apply the first formula GCD of m comma n equal to GCD of n comma m mod n. If you apply that formula, it becomes GCD of 12 comma 8. Then apply repeatedly. GCD of 12 comma 8 becomes GCD of 8 comma 4. GCD of 8 comma 4 becomes GCD of 4 comma 0. When any one of the input is 0, that is the final answer. GCD of 4 comma 0. The other number not equal to 0 is 4. So that is the GCD. Pause the video and try to write a pseudocode of your own. So GCD of m comma n. If the second number is not equal to 0, you have to apply the first step repeatedly again and again. So this is the pseudocode. Thanks for watching the video. Let us meet in another video. Thank you.